Unit 2.6, logic with Venn diagrams. Alright, so Venn diagrams are just a way to represent the relationship between your P's and your Q's, right? It's technically a way to represent a relationship between anything, but we specifically have been working with P's and Q's. So there are different types of Venn diagrams, right? The first type, all elements of P are elements of Q, right? So for example, if P was 2, then you could say Q is even numbers, right? All 2's are even numbers, but not all even numbers are 2's. But all 2's are even numbers, so it can go inside the circle. Right? Some elements, the key term here is some elements of P are elements of Q, and these are your most common Venn diagrams, right? These are your cats and dogs, right? They have differences, right? They're both animals. They have some things in common. Both have 4 legs. Both have tails, right? But they do have differences. Things that are just for cats, they meow. Dogs bark, right? But they do have some similarities, right? Some elements of P are elements of Q. They have some things in common. And the last one is there is no relationship between P and Q. These are 2 completely separate concepts. They have no overlap. They have nothing in common. They share nothing, right? So for example, you could say dogs, and you could say chairs. Well, no, technically they have something in common. They both have 4 legs. But you get the idea. It's 2 things that are completely unrelated. And you could do something obvious, right? Odd numbers, even numbers. There are no odd numbers that are also even numbers. There are no even numbers that are also odd numbers. They are 2 separate categories, right? So look for the key terms. All means you can combine them. Some means that there is some overlap. And no or never means there is no overlap. Right, so some students who take chorus also take band. Some is your second graph, the one that overlaps a little bit, and you have chorus and you have band. No perfect squares are prime numbers. That's your third chart, right? There are 2 separate concepts. There are perfect squares and there are prime numbers, but there are none that overlap. There are no prime numbers that are perfect squares, and there are no perfect squares that are prime numbers, period. 3, numbers divisible by 6 are always, that's your first chart, divisible by 3. So most of the time, whatever number comes first goes in the little circle, and then whatever comes second goes in the big circle. You can ask yourself, are all numbers that are divisible by 6 also divisible by 3? Yes. But if it was the other way around, are all numbers that are divisible by 3 also divisible by 6? No. 15 is divisible by 3, but it's not divisible by 6. Right? So this one isn't true. The 6 has to go in the center to make this true. Right? For every natural number, every, always, all, right? So natural numbers in the center, and a whole number is on the outside. And again, you can double check this, right? All natural numbers are whole numbers. Yes. Are all whole numbers natural numbers? No. W can't go in the circle. Only natural numbers can go in the circle. All right, you do 5 and 6. Pause it, do 5 and 6, and then come back and see what you got. All right, 5. Some, which means they overlap. Vertical angles are complementary. Is that what you got? I hope that's what you got. Some was your key word. And then 6. Never, so they're completely separate concepts. Irrational numbers are never rational numbers. Separate concept. How'd you do? Alright. This is parts shaded, and we can actually use this to represent logic, our P's and Q's, right? So, if we see this, if P then Q, because if P then Q has to be true. If P then Q, that's your P then Q. If P then Q. Alright? P or Q, because everything is colored in, it's P or Q. P or Q, and because it has to be P and Q, it's only this part in the middle, then it's P and Q. Right? That's the only piece that's both P and Q, the overlap. Alright, but we can take this further, right? We can bring in negations. So let's think about it. It says shade the indicated region on the Venn diagram. This one says shade Q. That's easy enough. Let's shade Q. Done. This one says P and not Q. Alright, so instead of just shading P, we have to take out Q, which means we have to take out the overlap. So we're only going to shade P but not Q. P but not Q. Make sense? 9 gets a little more complicated. You got to do what's inside the parentheses first. Q and R. So what is Q and R? Let's see. Q and R is this piece right here. Right? It's the overlap between Q and R. Now it says P or Q and R. So we're going to do P or the overlap of Q and R, which means we can use all of this. Right? So we can do all of P and Q or Q and R. Which means you also get this piece. Because it's an or. Right? So any of this, any of P, or any of the Q and R. So you have to start inside the parentheses and work your way out. This is easier with a pencil because you can just erase part of it. Alright, and then lastly, you need to be able to describe the diagram using a conditional or compound statement. Alright, so the first thing you might want to do is figure out what the statement is telling you. Remember, if then, this is an if then, so we already know it's going to be a conditional statement. It's going to be conditional. So now all we have to do is write it as an if then conditional statement. If angles that measure 60 degrees, then they are also acute angles. Right? If then. If an angle, just make it make sense, right? Once you have the words, you have to make it make sense. If an angle measures 60 degrees, then it is always, right, that's our code word, an acute angle. Right? Because it's on the inside, our code word is always. So I picked out what I understood. I understood that this was an if-then conditional statement, and I understood it was an always statement. So then I just wrote it in a way that made sense. If an angle measures 60 degrees, then it is always an acute angle. All right, 11. Again, we have an if-then conditional statement. If-then conditional statements. Again, it's an always statement. Now we just have to write it in a way that makes sense. All beagles, if it's a beagle, then it's a dog. If it's a beagle, then it's always a dog. If it is a beagle, then it is always, that's our keyword, a dog. If it's a beagle, then it's a dog. There are no beagles that aren't dogs. There are no 60-degree angles that aren't acute angles. They go inside each other. It's always. All right, 12. Because only the overlap is shaded, it's going to be a P and Q, right? It's going to be a P and Q compound statement. Compound. I'm just putting this for my knowledge so that I know what the answer should look like. Because it's a compound statement, it should have and or. And because it's P and Q, the information should be connected with an and. So, however you want to word this. Some people who play volleyball, because that's our code word, right? Some also take piano lessons. Or, let's see, people who play volleyball and take piano lessons. You see how I'm playing with the sentence? You can write it in a way that makes sense as long as it matches your diagram, right? So, let's see, people who play volleyball and is your keyword there, and take piano lessons. As long as your sentence matches your diagram, then there's no wrong sentence. Right? You can word this however you want as long as it matches the diagram. All right? See if you can pause it, because this one's a little bit different. Let's go ahead and figure out the P and Q part, right? So we're going to do P and not Q, right? This is your P, this is your Q. We don't want Q because we don't want the overlap. So we're going to do P and not Q. All right, now pause it and see if you can figure out what your sentence would look like. Okay, remember the keyword here can be some. Some is a good way to start. Some months have 31 days and do not, right? That's our not, that's our negation. Start with J. Again, there are several different ways you can write this. as long as it matches your diagram. You could have said months with 31 days and not months with, this start with J. As long as you said and not, right? And not. That's the important part. Some tells you it's an overlapping diagram, and the and not tells you that there's a negation in there. All right, same thing, 14. This time with our P and Q, we have a Q and not P, right? So we have a Q and not P, because that's the part that's shaded, right? Freshman, but not art class, right? Freshmen are not allowed, I like that better, to take art class. So freshmen, but not art. I don't know, for some reason that sounds better to me. If you do want to go the other way around, use the sum, right? Some are freshmen, but none in art class. More than one correct answer as long as it matches your diagram. And then the last one. Pause it, see if you can figure out what it's trying to say and how you would say it. Alright, because everything is shaded in, it's an or, right? Because it's P or Q. Everything is shaded in. P or Q. Right? So, multiples of 7, there are numbers that are multiples of 7 or even numbers. There are numbers that are multiples of 7, or, right, that's our word here, or even numbers. Right? Because it's or, everything qualifies. Everything gets shaded. So, important thing to remember. If it's just the overlap, that's your and. If it's everything, it's probably an or. If there's a part missing from the circle, that's a negation. And if it's inside the circle, that's if then. Right? If this, then that. If this, then that. Right? Look for your key terms. Always, some, and we didn't have any no's, nots, and nevers.